Possible causes of metabolic acidosis include severe diarrhea. During severe diarrhea, bicarbonate-rich intestinal and pancreatic secretions do not have enough time to be reabsorbed. This will lead to a decrease in bicarbonate in the body, which will result in an increase in hydrogen ion concentrations. The kidneys are involved in eliminating metabolic acids. When the kidneys fail, the metabolic acids accumulate in the body, bringing about acidosis. Untreated diabetes mellitus causes an increase in acetyl-CoA. Acetyl-CoA undergoes ketogenesis to produce ketone bodies as an alternative energy source. This leads to ketoacidosis. During starvation, after all the triglyceride stores have been used, proteins begin to be broken down. Oxidative deamination of the proteins leads to the formation of keto acids. Beta oxidation of fatty acids leads to the formation of acetyl-CoA. Recall that acetyl-CoA can be converted into ketones during ketogenesis. Ketones then can be used as an alternative energy source. This condition is called ketosis. Let's look at some possible causes of metabolic alkalosis. This is not as common. Overeating antacids can bring this about, as well as vomiting. During vomiting, the hydrochloric acid in the gastric secretions are eliminated from the body. This will lead to an increase in pH. Let's look at how you diagnose whether a patient has a metabolic or a respiratory disorder. We're going to use the saying ROME, where R stands for respiratory, O for opposite, M for metabolic, and E for equal. During respiratory disorders, we're going to be looking at carbon dioxide as well as pH. So let's start with respiratory acidosis. In this situation, we know that the pH is low. So you'll have a decrease in pH, but you're also going to have an increase in the partial pressure of carbon dioxide. That's the opposite relationship. Remember, there's a direct relationship between partial pressure of carbon dioxide and pH. For respiratory alkalosis, what we're going to see is the opposite. During respiratory alkalosis, you will have an increase in pH and a decrease in the partial pressure of carbon dioxide. Let's move on to metabolic acidosis. We'll be looking at pH as well as bicarbonate here, but they're going to go in the same direction. For metabolic acidosis, you will have a decrease in pH as well as a decrease in bicarbonate ions. For metabolic alkalosis, you will have an increase in pH and an increase in bicarbonate ions. Whenever you do a blood workup, you're going to be looking for these relationships. If you look at the top here, this is the normal arterial blood gas values. And then at the bottom, you have a patient. Notice that the pH of the patient is low. So this patient is experiencing acidosis. Carbon dioxide levels are elevated, oxygen is normal, and bicarbonate is normal. Since the pH drops and the carbon dioxide goes up in opposite directions, this is going to be respiratory acidosis. If this was metabolic acidosis, the pH would drop and the bicarbonate ions would be below normal as well.